I want to show you how to draw Lewis structures for polyatomic ions. Polyatomic ions are a little more complex than just a regular molecule, so they require some special steps when we're drawing Lewis structures. The great thing is, you don't have to do anything different than all of the other Lewis structures that we've drawn together, because polyatomic ions are built into the rules. Now, if this is the first time you're seeing this, you need to write this down because this is the steps that we're going to go through to draw all of our Lewis structures. But if you have been following along, this is where we're going to get into step 4, where we add brackets and the charge if the molecule has a formal charge. We haven't done any of these yet up to this point, so let's start. It's important that you know what polyatomic ions are before we start to draw them. If we break it up into its name, it's really quite helpful. Polyatomic ion is many atom ions. So these are held together by covalent bonds, which is why we're learning about them right now and drawing Lewis structures for them, because we don't draw Lewis structures for ionically bonded compounds, only for covalently bonded. But here's the thing. When the structure formed covalently, extra electrons had to show up or electrons have to leave. I'll walk you through that and it'll make sense. It's just going to have to kind of do these together, but that's why we have a charge over here. It's showing us that this whole compound has an overall charge. If it has a positive charge, it would go and attach itself to something that has a negative charge, right, in an ionic bond, even though it's held together with covalent bonds. These molecules live together as one unit. They have an overall charge, and they'll be ionically attracted to something with an opposite charge. The formal charge, which is what this is called right up here, is for the entire compound. It's not just for one of the hydrogens or for the nitrogen. It's the whole compound. And as you're learning these, you're going to find out that most of them end in ate or ite. That's kind of the indicator that we're dealing with a polyatomic ion. But not all of them end in ate or ite, just the ones that have oxygen in them. We did cover this in an earlier lesson. I'll put a link to it down there if you need help. Your best bet is to have a chart of polyatomic ions. You can find those. I'll have a link in the description. Periodic tables that we use have a box included on the back, on the bottom, in the middle, and that's a good reference. But you can look them up as well, or you can go down there and find a help sheet. And the best way to learn how to do them is to just do an example together. So let's start with the ammonium ion, which is a nitrogen that has 4 hydrogens attached to it, and it has a positive charge. You saw it on the last slide, but we need to know, well, how did I draw that? Like, where did I come up with that structure? We're going to add up the valence electrons from all the elements in the molecule. I always do this the same way for everything I do to ensure that every Lewis structure I ever draw is correct. I'm saying I have a nitrogen and only one of those. I do have hydrogen in my compound, 4 of them. Then I come over and I find them on the periodic table. There's nitrogen. Nitrogen is in group 1, 2, 3, 4, 5A. So every nitrogen has 5 valence electrons. We have one of them that's going to show up to our little party that we're going to start here, which means nitrogens are bringing 5 valence electrons to our party. We have 4 hydrogens showing up, and each hydrogen is in, well, this is group 1, which means it has 1 valence electron. So, but we have 4 of them, right? That gives us 4 valence electrons from the hydrogens. Let's add them up. 5 plus 4 is 9. The E negative is just shorthand for electrons. So I've got 9 electrons to build my structure. And this is where I need to be really careful, because right here, add or subtract electrons to reach the formal charge. Does this have a formal charge? Yes, that right there tells us the formal charge. If this has a positive formal charge, that means something about its electrons. Here's what it means. If something has a positive charge, one of its negative electrons must have gone away. So now it has more protons than electrons. If one electron leaves, that means it has one more proton than it does electrons, so the whole thing's going to have a positive charge. Now, what if that was negative up there? If that was negative, that would mean an electron had to show up and it attached to our compound, and now it has an overall negative charge. I tell you this and I stress it because we can't think of this as a math problem. We have to think of it conceptually, and that's why I write the E negative, to remind myself, right now I have 9 electrons. But when this formed, what happened to one of those electrons? one of the electrons went away. That's why it has a positive charge. So I need to remember to remove an electron from my total. That means I actually only have 8 electrons to build my structure, not 9, because it has a positive charge, which means one of those left. You'll see why one of them left. There's nowhere for it to live on our Lewis structure. Let's get there. Build the skeleton structure with the bonds. Remember, lowest electronegativity is going to go in the middle. And the hydrogen might have lower electronegativity, but it won't be the middle of anything. So I'm going to put my nitrogen in the middle. I'm going to branch, let's see, 4 hydrogens off of there. So I'm just going to draw in 4 bonds, all at right angles. And then I'll go ahead and plot my hydrogens at the end of those 4 bonds, like so. And that's my skeleton structure. Now I need to add electrons around the outside of the molecule. I need to use all of them from step 1. So 8 electrons. Let's get up here. So far, I've used 2, 4, 6, 8. Well, wait a minute. That's all of them. I can't put any more electrons on here because I only calculated 8. But that should make sense. If we look, hydrogen can't hold any more. This hydrogen can't hold it. That one. None of the hydrogens can hold any more electrons. And nitrogen's filled up. It has 2, 4, 6, 8 around it. So when we were right here with 9 electrons, if we would have stopped there, where would the other electron go? There's nowhere for it to live, and that's the point, right? When this thing formed, one of the electrons, there was nowhere for it to exist, so it just had to go somewhere else, which is why this now has an overall positive charge, which means we need to do number 4, add brackets and the charge if this has a formal charge. Here's what brackets are. I just put it around like this. The purpose of adding the brackets is to show that this positive charge right here belongs to that entire molecule. And that whole thing can go ionically bond to something with a negative charge. So this is the Lewis structure for our ammonium ion. Let's try out the hydronium ion. We'll work through this one together and see what we get. If you're feeling confident, just pause the video and try it on your own, and then you can check the answer with me. I need to add up my valence electrons. So I have 3 hydrogens and I have 1 oxygen. Hydrogen over here is in group 1A. So each hydrogen is going to bring 1 valence electron to the party, but there are 3 that are going to show up. So we'll have a total of 3 electrons coming from the hydrogens. Oxygen, I find it over here, is in group 1, 2, 3, 4, 5, 6. So oxygen has 6 valence electrons, and that means I have 6 plus 3 is 9 electrons to build my structure. That's this part. Don't ever forget to check for the formal charge though. So we look up here and there we go. We see that positive again. And if you remember from our last example, when it's positive, it means that a negatively charged electron left. It left our compound. And when the negatively charged electron left, it meant that now the overall compound charge is positive because one of the negative things went away. So what do I need to do down here? I need to be careful. I need to remember if this is positive, then one of these negative things left. I need to get rid of one of those negative things. And now I have 8 electrons to build my structure. What's going to go in the middle? We said hydrogen will never be the middle of anything. So I'm going to put the oxygen there. I'm not really sure where these hydrogens go. You don't need to know where they go. We just need to put them on there somewhere. I'll put it like this for now. And we have hydrogen, 3 of those, oxygen, 1. That is our skeleton structure. Number 3, add up the electrons, put them around the outside of the molecule. I need to have 8 on this, and I've got 2, 4, 6. So where do the other 2 go? They can't go on the hydrogens because those are full. But oxygen does not yet have 8 electrons, so they must go on the oxygen right here. Number 4, add brackets and charge if it has a formal charge, which it does. So I'm going to put the brackets around this, like so. And then I'm going to write the charge up here, which is positive. I'll use my blue because I think that green's really hard to see. And if I check well, we don't have resonance structures yet. I'll show you those on another lesson. And then check our answer. Hydrogen has 2, 2, 2. Oxygen has 2, 4, 6, 8. This does have a formal charge. I have brackets and the charge up there. This is the hydronium ion. We're going to try one more together, and this one has a negative formal charge. I'm doing this one just to show you how to deal with that. It's a good idea to pause the video, work through this on your own, see what you get for an answer, and then you can start the video and check your answer. Number 1, let's break up our hydroxide. Oxygen, we have 1. Hydrogen, we have 1. Each oxygen, I'm going to find it over here, right there, is in group 1, 2, 3, 4, 5, 6. So oxygen has 6 valence electrons. We only have 1 of them. Now, some of you are saying, I don't know why he keeps doing it that way. It'd be way faster if he just did it in his head or did it. Because I want to keep it consistent for the people who aren't super confident about doing this. But also, as these become more complex, if I'm used to doing it this way, even if it takes an extra 1 second or 2 seconds, that consistency ensures that I'm always going to get it right. And if you follow along, it ensures that you're always going to get it right. Hydrogen is over here in group 1, has 1 valence electron. One of them is going to show up to our party. We add these up. We have 7 electrons to build the whole thing. We've finished this part, but we don't want to forget about the formal charge, right? And we look here, this does have a formal charge. I picked this one because it has a negative formal charge. Think about this. If this hydroxide has a negative charge, that must mean that a negatively charged electron came and joined the party. It had to, because you'll see when we draw this, if another electron didn't come in and join the party, we would not be able to build our structure according to the rules. It would not be correct. So right down here, I need to show that another negatively charged electron is going to show up, and that gives us 8 electrons to build our structure. I realize in all of our examples, it's been 8 electrons. It won't always be that way. I'm just kind of trying to pick more simple ones for time. But once you understand how to do all of these steps, you can draw any Lewis structure. Let's put our oxygen in the middle. And I need to attach 1 hydrogen somewhere to that thing. So we'll put it right there. Not really sure what direction it goes, and it does not matter at this point. Right now I've used 2 electrons. Let's come over here and get rid of some of these. That's my skeleton structure. We're going to add electrons till we've used them up. I've used 2. Now, hydrogen can't take any more, so I'm not going to put any more on the hydrogen. I'm going to put them over here. I've used 2, 3, 4, 5, 6, 7, 8. Well, that's how many I have. Again, let's go back. What if we were only at 7 and we forgot to do the formal charge part? This wouldn't be correct because we would be missing one of our electrons. And this is not, that oxygen is not full, which is why an electron needed to show up to really finish out this structure. We come to the next one. It says add brackets if it has a formal charge. Yes, this does have a formal charge, so we'll put it like that. And the formal charge was negative. I draw it out here to show that that whole compound or that whole molecule has a negative formal charge. If you're looking for more practice with Lewis structures, I've got some links down there in the description where I've got lots of worksheets and handouts and things to help you learn this. I've also got things over at bealsscience.com and bealsscienceschool.com, resources, worksheets, practice, more things so that you can get really good at drawing Lewis structures. And when you're ready for the next step, watch the next video, which is where we're going to deal with, wow, what if we end up with something that needs to have a double bond or something that needs to have a triple bond? What do we do? We'll find out in the next video. Stick with me and keep on learning.